We have our XPSWM and XPSTORM team online today. Tony Kuch, Superman, our Vice President of North American Operations and Client Services, and also product owner of XPSWM and XPSTORM, has been with XP Solutions since the dawn of time. 22 years, this January. He's trained thousands of XP users, provided technical and engineering support, and continues to drive the development of the software. Adam Rose, our Water and Sewer Products Manager, has been with the company for 24 months now. Though he's one of our newer products managers, he's also been very busy developing a soon-to-be-released program for water distribution called XP Water, so stay tuned for that in the coming months. And he's been our resident sewer guru as well. Some of you may have seen one or many of his insightful sanitary sewer or GIS webinars. Both men have an amazing knowledge and dedication to modeling, and are here to present XPSWM and XPSTORM version 2016. Tony, take it away.
Thanks, Nicole. So we're going to talk today about XPSWM and XPSTORM 2016 development. We're quite excited about this release, and we're going to discuss with you in this 1-hour webinar, some of the major new features or significant changes that you see in the software. We'll use some PowerPoints and do some live demonstration on the things that, maybe warrant more of a demonstration. And throughout the webinar, we're going to have an opportunity to answer any questions that you type in. And at the end, we'll stay open for several minutes afterwards to answer any questions that we didn't get to during the hour. Both Adam and I are online, and so us and any other of our engineers that are on will tackle your questions as they come. So about the changes for 2016, really it was quite diverse. We tackled quite a bit of stuff. For example, we went at the interface look and feel and the productivity of the software, using your comments, for example, on where your workflow was inhibited by the software and could be enhanced. We've got new features and enhancements, generally speaking, throughout all different parts of the software. We even have a new object. So in the sanitary area, where Adam's going to talk to you about later in the webinar, there's a new layer of objects to support sanitary sewer modeling. Of course, we've enhanced the engineering and the computations that go on behind the scenes and within the interface and the analysis engine. We've moved the help to an online wiki system. There's several advantages about a wiki system, but we're going to talk more in the detail about these things later, and of course lots of general software maintenance. We've grouped the different things to talk to you about. So I'm going to start my discussion today with you about model building and setup enhancements that are in the software. Very generic, but there's a diverse set of things. The first thing that you'll notice is that the software look is somewhat different. For example, we're starting to use some of our newly derived graphics throughout the program. So here's an example in the opening banner. So one way to quickly distinguish what version you've launched is maybe by the opening banner. You can tell here the version number or database number is 17 with the licensing. And of course the software itself has various changes. We integrated something called the MFC feature pack as part of the development kit, which has allowed us to have enhanced tooltips. So that will be something that's noticeably different. And tab dialogues, which are color-coded. The tab dialogues allow you to simply grab one of these windows and drag it and move it to a different place. For example, within my XPSWM application here, I have 3 different windows tiled together. They can each individually be clicked or moved, or you could resize any one of these panes, I suppose. Once they're tiled together, they're panes, just by clicking on the dividing bar and sliding it one way or the other. So that's definitely something that's very different about the software, generally speaking, in its appearance. We've also tagged various license types. For example, this screen capture was done with a training version of the software, and there's a watermark for training versions and evaluation versions which appear in the dialog. One of the features that we tackled, which arguably from our end was one of the things that took the most amount of time because of how embedded into the software it was we've increased the node and link label sizes. So the objects can now have up to 80 characters in length. Previously it was 10 characters. Those of you very familiar with the software, perhaps you've tried to use names longer than 10 characters in the past. You may have noticed when you imported, say from GIS, when names were longer than 10, you had a default name, and then the description field would take in the longer name. You could have displayed the description, but now we've got the database indexing essentially to show the object full name up to 80 characters in length. Now, some of you are familiar with the software and know that the text output file from a simulation solve is very formatted text, and to allow that to be any length between 0 and 80 would have made very awkward looking tables. And so we've capped those names to 20 characters in the table, and if your name happens to be more than 20, then there's a bit of table of contents inside of the output file, and a substitute database ID is used in the output file, and then the table of contents refers a database ID to the longer name that you're seeing on the screen. And so, you can definitely just search and replace if you like, or if you weren't worried about the way that the table would look in a text file. So yeah, this was one of the bigger changes, one of the things that caused us the most amount of development time, but something that we were really excited to bring forward so that we could not have the length issue that was existing in the software for a long time. One of the newer features, which I'm going to also demonstrate in just a few minutes, is the ability to take catchments. So there's a catchments layer in the software, and that's essentially a set of polygons which can be imported. If your source, for example, had data that said that a certain catchment was drained to a particular node, it's possible when you import it to make that association. But let's assume you freehand draw the catchments, or the catchments that you import don't have the data to say where they drain to. There's a new tool under the Tools menu, quite appropriate, under Calculate Node, and it has Catchment Drainage. And what it does is it brings up this dialog. It shows all of the catchments that are in the model, and then the nodes wherever it would follow in one of these rules. For example, that the node happens to be in the catchment. And when you click here, it's like a pick list, and you'll see all the nodes within the catchment. You can pick whatever one, and of course the tick box would make that association. You can similarly find the nodes that are closest to a centroid. Why a centroid? Perhaps that might just be an appropriate way when it's very undescribed surface. And then nearest a vertex. Why nearest a vertex? Well, if you think about it, a catchment is described from a point and everything upstream that would drain to that point. So if there's a node near a vertex, say at the low point, that might be a logical place to say that all of the water in that catchment would drain to this point. Of course, there's all nodes in the model, and you can simply just pick whatever catchment and node combination that you'd like. In order to know which catchment is which, there's catchment IDs. Currently the IDs are just incremental numbers, the word catchment and then 1 through infinity. But this is giving you that ability to see on the screen which one that you want to associate. Now this is just a tabular view. It's just maybe a little faster than graphically attaching them, which is still the case. That's another option where you would simply pick the polygon, click on the centroid, drag to the destination node to make the attachment. So it's supplemental to that approach. Another example of some of the tools that we've done in the dialogues to make them more efficient is, for example, for the Orifice area. Since area is the required value for the analysis, but people are maybe more familiar with their choice of size of orifice, meaning like the diameter or the height and width, we automatically will calculate for you with the calc button. You'll bring the dialog up, choose circular, rectangular, put in the dimensions, click OK, and it will return the area which ultimately was required before for the analysis to proceed. So just a little bit of a productivity tool as far as orifice area calculations. Another example of what we've done to make the software more productive, to keep that workflow efficient, is whenever that you are going into a dialog that will accept a list. Here's two examples, but of course there's more. For example, time versus flow hydrograph, or station versus elevation for a natural channel shape, will already create a first row for you, so that if you are copying from another program like Excel, you would simply just need to click on the first row, first column, and then right-click and choose Paste in order to populate the list. Previously, you would have to press the Insert button, and then you would get your first row, but now we're just going to start the dialog with the first row. So a really small item, but multiplied by the number of times that you might go into dialogues and be pasting, it ends up being a significant productivity enhancement. Next, I want to talk about our concept of configuration parameters. Some of you know that there are many configuration parameters. Some are esoteric, some in fact are quite useful and used frequently. We've basically evaluated that the configuration parameter called ZREF equals, or ZREF for those of you not in the USA, where you can initialize a model to a certain water elevation, was used quite often, especially when you had a fixed backwater elevation and you wanted everything in the model flooded to a certain level. In fact, it's so commonly used, we thought that we would expose that now in 2016 into the hydraulics job control, where you can tick the initial water surface elevation and then put in the value. So you're no longer required to use a configuration parameter, which seems a little bit mysterious or, super advanced modeling geek work. Rather now, it's presented up front in the job control of hydraulics. And over time, you will see more of these types of features of the software brought, into the interface where, it's easily exposed and discussed and, for example, getting help on the feature. We also have had a request from users to know what version, what version and what license number last edited a model. And so if you go into the File menu and choose Properties, you'll see a last saved by. And so, for example, the last license to edit the model that was open when I made this screen capture was 42, meaning SWM, 1700, which is 2016, and then license number 0001. Well, in fact, that's my license number, and it's a full license. If it was an evaluation license, you'd see E here, for example. If it was an academic license, you would find an A as another example. So that was maybe just more general things, but now specifically for 2D models, we've made some enhancements, which I'm excited to talk about. The first is mostly for our US-based user base. So the analysis engine, XP2D, which is powered by 2Flow, has had for a few years the ability to directly solve in US units. Originally that wasn't the case, and it would only solve in metric units. And so when we created XP2D, we pre and post processed the modeling into metric. So you'd have a US unit model, then we would make the metric equivalent, we would analyze it, we would get metric results, we would post-process them, bring them back into the interface. So your experience perhaps was always in US units, but behind the scenes it was in metric. Well, what we've done in 2016 is we allow you to choose that you will use your project units for the 2D engine. This means that the underlying calculations will be in US units as well. There won't be a conversion being done. This means the advanced capabilities of the two-flow engine, such as the ability to create grid files, will already be in US units, and it won't require you to take any kind of intermediate or raw results and have to make a conversion from metric to US when you want to take them directly into GIS. So it's kind of a little bit more on the power user end, but it really opens up lots of opportunities for you to use raw calculated results from the 2D engine or two-flow directly in the same units that you're doing your project in. Another example about where we've made some advancements in the 2D modeling is the 2D results difference. Perhaps some of you even attended our previous What's New in 2014 and learned about the 2D utility interface. And in that 2D utility interface, there was the ability to create a difference file between two XMDF results. While this existed, it created an XMDF file. However, that file that was created could not be directly used in the XPSWM interface. And what we've done is we've bridged that gap, and we allow you to right-click, add an XMDF results file, perhaps the one that is the difference file, and load that with any of your other 2D model results which are in the plan view. So it sort of completes that process, perhaps where we could make a 2D results difference file before, couldn't directly use it, third-party tools could have used it. Now we're saying, well, the XPSWM interface can manage a results difference file as well. Something else that we're pretty excited about, especially for the 2D modelers, and they want to look at the impact of different alternatives. The the error messages that come from the 2D model are essentially spatial in nature. They're spatial in that, you know, the errors or the warnings that may happen may be on a certain cell. In a 1D model, of course, you could create a table and say link number or name or node name has this problem. Well, in a 2D model, you don't really look at the name of each cell, since there can be, in some cases, millions of them. And so you look at these errors and warnings in a spatial way. And what we've done to the program for 2016 is we've allowed you to toggle on or off the various types of messages, such as error messages or warning messages, and they each have their own unique color. So I've seen cases where there's been hundreds of messages on the screen. Perhaps most of them are warning or check messages, and there's 3 error messages, and it's just hard to locate the few error messages when they're all the same color and everything is on the screen at once. So of course now you can perhaps just show the error messages, the things that are preventing the model from running, or you'll just notice them in a red color rather than in some other color, and so it's easy to pick them out in the plan view. Another feature that's happened in 2016 for 2D modeling is related to evacuation routes. So the evacuation routes have a summary. Those of you unfamiliar with them, essentially they're a polyline that you draw, typically like on a road or a pathway that people would use to evacuate a flood. And then it reports graphically and in a table for how long and where and when, etc., that the route is first cut off. What we've done is allowed these evacuation routes to be supported by global storms and scenarios. So there's a different summary for each one that can be brought up in the interface, but also we are specifically saying in the report what is the X and Y location. So you're easting, northing of where this issue occurred. All right, I have a little bit of a live demo where I wanted to talk about the long object names, maybe just demonstrate that for you. The catchment drainage, perhaps I can link a few catchments using some of the rules, and then I'll look at about the loading of a XMDF results file, a difference file for the 2D model. So let me switch over to my XPSWM model that I've got teed up for you. It's called Catchment Drainage. I'll give it just a moment to put all the graphics through the internet to your screens. I think I'll also clear it up by not showing any longer the background image. That'll make things just a little bit more obvious as you're trying to follow with me. For example, how about the long names? So for example, I can just simply go and make a longer name like this is the junction node. I can solve the model then with that longer name. And if I was to review the model results, then you'll notice that the long name is supported. Here's the two different tabs. Remember I told you about the tab dialog, so I can just tear this tab off and put it to the different part of the screen for me. I can have both things opened at once. Let's close that. And I also mentioned to you that the output file, whenever this is more than 20 characters, is going to be using like a little bit of a indexing or a table of contents. So perhaps since I feel like I have a couple more minutes before I turn the time over to Adam, so let me go in here and just show you at the top of the model's output file as soon as I get there. You'll see that there's a small table here that shows whatever ID is going to be used in the output file for a substitution for this very long name. The font used in the output file is Courier, and so it's a proportional font. It allows everything to line up when you get into tables. And hence, if we allowed this, for example, this name field to be anything more than 20 characters, then of course nothing would line up and it wouldn't be presented very well in the text output file. That's why we said for the output file we will end up using this substitution, if you will, ID star, and then a number. But of course that really means, this part right here, it really means from the table of contents the long name that's being presented in the output file. All right, so let's get back to what I ultimately wanted to talk about, which was the catchment connections, the catchment drainage. Of course, previously you could go in and just grab the centroid, drag and drop it on a node, and then say, well, this node or this catchment is draining to this certain catchment position for that node. Well, what we've done is under the Tools menu, as I've mentioned, we have a Calculate Node Catchment Drainage. So again, this is if you haven't imported catchments with a destination node already. So here I am in the new tool. Actually, I'll do one more thing before I go there. I'll put on the labels for each of the catchments. So for example, this catchment 18. We'll look at this one, this catchment 18. So catchment drainage again, I'll move this off to the side so I don't cover up too many of the catchment labels. Now, the tick box at the top, this is like the master switch. So if you wanted it to just do it by whatever node was contained within a catchment, it would tick all of those. But ideally, or realistically, you would have to go in and make choices for each one. For example, catchment 18, I know from experience, like doing this tutorial before, that actually everything is supposed to be draining to node 3.1. So it does happen to be a node contained within the catchment, but if there are more, and in fact there are 3 nodes that are found within that catchment polygon, you would choose whichever one you want. I'll pick 3.1. The node nearest the centroid is, for catchment 18, is node 3.2. The node nearest a vertex happens to be a different node called, this is the junction node name. So hence, you can make some various connections. I'll just pick a few. For example, I'll try not to pick a conflict of any of these. Maybe number 10, I will say it goes to, I don't know, 5.2. So let's see, I'm doing a 5.2, a 5.4, a 3.1, etc. I'll click OK, and then various catchments are connected by whatever rule I had picked there. That table that you saw is available like for copy paste, so if you had the rule that you set up elsewhere, you could just go in and copy and paste, of course, and then clicking OK will make all of those assignments. Let me switch to my second model, which is a 1D, 2D model, where we're going to be able to have a difference being calculated and maybe display the difference. I'll give this just a moment to appear on your screens, and I can talk about a couple of the other things that I mentioned previously. So the first thing is that you'll notice there are various sets of messages in the diagnostics. So I don't have any errors because this model did run, but I could go to the data section and then maybe only leave on the warning messages, believing them to be somewhat significant, right? And so I'll be left with only the warning messages on the screen. So perhaps you can see from that, that you would be able to just show the errors, for example, as you would, filter out the messages that are on the screen. I'm currently showing in this model the base scenario and the maximum water depth. I've also exported the maximum water depth to a shapefile, and I have that shapefile loaded here under GIS files, which is the dark line, the black line, showing the the 0 for this extent of flooding. Now I've created a scenario, and my scenario is called conveyance, and my conveyance scenario is that the links and nodes that join the stream in the south and north have all had their number of barrels increased from 3 to 4. So I've added more, if you will, I've added more conveyance in the storm sewer system to try to alleviate some of the surface flooding from the river overflow. And sure enough, it has, because the black line is my flood extent from the base scenario, and then with the conveyance, when I'm now showing maximum water depth, it doesn't go out as far. So there's less flooding, and there's going to be a difference, if you will, in the depths in the various parts of the model. So the tool that I've talked about for the difference is under the Tools menu, XP2D Interface Utility, and it's about this 2D results difference. So the procedure is that you would pick in the software, let me go to the correct folder where these model results are. You would go to, say, the 2D output folder, and you would pick, say, the main run was this one, the one with the buildings in it, and then likewise you would go and choose the other one that you want to do a difference to. And I guess if you want to know about the minimum requirement is it has the same grid geometry. So it can't compare, a model from one city versus another, but the same geographic location, you're going to be able to make the comparison, and then you would pick the other one to do the difference with, and then you can assign a difference output. So I guess I'll just assign a new one here. So I already actually did this, but this is the process. So you'd pick a difference XMDF and then execute it, and it will create, if you will, this new results file, which is the difference between these two. Once you have that difference created, then you can right-click on the 2D results. You can add the XMDF file, and you can load that difference result, and you'll notice that the difference result appears here as a new set of model results to look at. For example, I will choose to display for you, say, the maximum water depth difference. So it's color graduated, if you will, right? And if I move my cursor in here, I can see, you know, the differences. So the difference here is only 10 centimeters. The difference here is 14 centimeters or 0.14 meters. This happened to be a metric model. You know, the difference in here was 0.05, etc. So how am I reading that? You know, I'm reading that down by the status bar over here whenever I'm hovering on that map. And so that difference is, you know, obviously a map that you can manipulate and you can export, etc. But it's, you know, quite useful, especially to know the impact on the surface flooding in the 2D simulation when you're using various you know, scenarios or global storms. So I believe that's all my demonstration, and back to Adam now to talk about some workflow enhancements. Adam, if you can take control now, that would be great.
Oh, I love taking control. So I have 3 sections: workflow enhancements, sanitary related things, and GIS related things. So let's start with some workflow enhancements. These are not totally dissimilar of some of the things that Tony talked about. So at the beginning, I'll talk about default templates. If you've listened to some of our trainings and webinars before, you know that templates are a really nice way to persist some of these changes that you make. As you know, XPSWM has a lot of different configurations and ways you can make things look. So a lot of people use templates, so we've made it easier now to start with a template. And so you can set the default template. So here you can see there's an option of new as just a new blank, or from default template, which is easy as a Control-T. And then you can see on the right side, you can set both a metric and US template in your configuration, so you can path to where it is. So me as a sanitary user, I would set my default US template to sanitary, and then I'd be good to go every time I needed to start something new. Even if I'm importing in, I would still start with that template. So that sets the way things look, it sets my XP tables, sets everything, so I'm a happy modeler, and then off I go. So kind of a nice workflow enhancement there. Next up is something we're calling maintenance. This is helping you out as a modeler. As you probably know, there are certain characters that you cannot use from a Windows environment. So you can't make a text file called \\\. And so certain files in the XPSWM environment are actually saved with that name appended to the file. So now, rather than either in global storms or scenarios, putting in a model that to you makes a lot of sense, like 1% model, and then getting all the way to try and execute the model and then getting an error, you now get an error right when you write it. So you can quickly fix it and then go about your way. So kind of a nice just-in-time warning there. Again, related to a Windows limitation, not an XPSWM limitation. Final thing, Tony mentioned it, and I will be demoing it in my little demo part. We do have an online wiki help, so when you hit your helpful F1 or path to help inside 2016, you will be taken to an online portal There's lots of nice reasons you can do that. Obviously, we have a lot more flexibility in how we can present to you the help documentation and other documentation, as well as nice things just from building HTML. So when you start typing in the search box, it'll auto-populate. It just does a lot of really nice features that you just can't do quite as well in the embedded robo-help style. So 3 quick things there, but all very useful. Now, if you are fortunate enough to be a sanitary sewer modeler, I'm going to cover a few different sewer enhancements. Pretty excited about these. One of these is related to SWM5. This isn't necessarily directly a sanitary sewer, but if you're importing from SWM5, EPA SWM5, we have a few enhancements. One related to the way you handle constant storage area nodes. So that would be a good example would be from sanitary a wet well. Also, the default abstraction, initial abstraction, is something that's been changed to handle better the import. Natural channels, importing that is a much easier process and more robust. And if you have inactive rows, we handle that better. And then, of course, name handling, that kind of goes part and parcel with what Tony talked about with having longer names. So, and there's more detail on that if you go to the changes.txt file, but that's kind of the highlights there. Over in the realm of RTK, we now have more precision. So you see your R values, that's your fraction of rainfall. If this is your first time seeing RTK, so now you can get out to the 10,000s. So if you have really, really, really precise data that you'd like to enter in there, we now support that. So you can see an example of that there. You can, of course, as always, get to that through global data. The big one that I'm talking about in the demo is the Sewershed Layer. So if you were looking ahead to what Tony was showing you, you might have seen that in addition to catchments under node, you see there's Sewershed, so it's its own layer and has a lot of similar functionality to catchments. But these are dry weather flow sewer sheds. So we will show how, or I will show a little bit of that functionality, again, not training, but at least to give you an idea, kind of whet the appetite for when you are doing that work yourself. Okay, final thing I'm going to cover before my little demo is some data/GIS enhancements. That's one of the hats I wear here. So I requested and was given the ability to talk to you about those. These are not all sanitary. They just kind of run the gambit of different data handling that we have in the program. The first one, and some of you I've talked to from support because you've run into issues when you're exporting your result grids and they're not quite right. You see a little bit of noise, maybe there's some flooding in just kind of a random spot, or their holes are showing up, and this is just because XPSWM will allow you to rotate your grid, the view of your grid, and when we're rotating back, sometimes we had a little bit of problems there at export. Well, we have made that much more robust, so there aren't an extra workaround now. It's just a direct shot. So I think a lot of you will appreciate that exporting. Second one is a 2D. So now on 2D reporting, and you can kind of see it there, if you do a right click, you can import from GIS file, whereas before you had to manually do this, and so it was not always exactly in the same place. Now you have the benefit of either importing in a polyline for flow, so if you have a shapefile that's a line, you can do the flow reporting, where it's summarizing flow, or if you're doing head and velocity, you can bring in a point shapefile. And now you know exactly where it is, and it's repeatable in your results. It's kind of a nice extra feature there. Speaking of formats, a lot of you use the external database wizard, and you may have known before that if you were using Excel, you had to save down into the older version of Excel, just the .xls. Well, now we've changed that to where you have the .xlsx, so you don't have to do the extra set of saving it. You can just directly import that. You kind of see that there in the select a file. Both XLS and XLSX are both available, which is a nice feature. Okay, on to rasters and background images. A lot of you, and you saw Tony had one, and a lot of people, for a lot of good reasons, have background images. Well, now we have the ability, through a little bit of a slider there, to change the background image transparency. You're basically whitening or lightening the image, and I will show you that as part of my demonstration. But so that's a nice feature. If you've got, in this case, some of your aerial may be really dark, and it's hard to see the nodes in those areas, you can lighten that up for better visibility. Speaking of graphics, another feature here, in Tools Export Graphics, you have the current view or network, but now we also are supporting the world file. So it has the spatial representation of where it is, so which is really nice. So you can export that, so you have your JPEG with the world file, which means if you open that file in your GIS platform, it'll come in where it belongs in that coordinate system. Or if you have an older XPSWM file and you want to open that up and create just the world file, it's a similar functionality to QGIS, so you can actually write just the world file for any given graphics, or do it all at once. So that's a nice feature. It makes your workflow easier when you're exporting out to doing any final processing in a GIS platform. One thing I'm really happy about, the Sewershed layer that you saw is not stored the same way everything else is stored. This is one of our first features stored in a SQLITE database. And in fact, even better than that, it's actually stored as SpatialIte. So for the GIS people out there, or for you that have GIS people not on the call, you can let them know that that is a spatial database. So it's our first foray into storing data natively in a spatial database. And what does that do for you? It does a number of things, but the most quick return thing I'll show you here is you see three images kind of laid on each other. On the far left, that is XPSWM 2016. May look a little different to you because it's 2016. We see that. And then the second one is QGIS, but it's equally viewable inside ArcMap, so ArcGIS. And on the far right, a web map. So this data format is an open format that you can run on your phone, on a website, on your desktop software. So really happy about that and looking forward to continuing to add more objects to it. So I'll do a little demo with you on that as well. In fact, I believe I'm on to my demo, and I'm going to try to keep this, Tony, to maybe 5 minutes so we have time at the end to be respectful of everyone's time. So let me start by bringing in, and again, hopefully everyone can see, it may take you a second on your screen, but I'm bringing in actually Esri ArcMap. So I'm going to start there, and you can see a sewer shed area, and that's this kind of mustard and ketchup colored area here. So I have a section here, and I'm going to show you bringing in from ArcMap that data into XPSWM, taking advantage of this new sewer shed connections. So there it looks on that side. I'm going to drag over XPSWM 2016. And I suppose I can show you the background transparency. So I'm in background images here, can right click to properties and look at the properties of this image, and there's the slider I mentioned before. So if I bring it into about halfway and I hit OK, I'll go back to my view, and you can see it's lighter now. So much easier to see this red text over this lighter image, which is a nice feature. Again, here we have sewer sheds. I'm going to do a right click, import from GIS file. So and a lot of you may be familiar with this from doing it from catchments. Even if you're a sewer user, you may have done your wet weather flow that way, but now we're going to do our dry weather flow that way. I have a sewer sheds file. I'm going to hit import, define the node name. In this case, it's name, and I can also define the dry weather flow pattern. So dry weather flow pattern, and hit import, and you can see here it read 7. I'm only doing these 7 right here, and it found them. If I hit OK, not only did it bring them in, but it actually assigned them already because I told it which dry weather flow record to bring in, which is really nice. This is also a nice automated way for those of you who have multiple dry weather flow records per manhole. You can now automatically bring them in versus having to manually do that, which for some of you that have really large models is a really appealing feature. So you can see here, here's my image. It's the same one as before. If I hit edit data, it's empty now. But as you recall before, it's pretty easy through our GIS link. I'm actually connecting this to the same DBF. So I imported a shapefile called sewer sheds. I've connected to the database of sewer sheds. There's the same data that you saw in Esri. If I hit OK, I read the 49 variables. If I close that and re-edit here, everything's there. Census-based. I have a flow rate, a density. Notice I have no area, but have no fear. If I go into Tools, Calculate Node, Sewer Shed Areas, my old area was 0, but because of the power of the shapefile, I have a new area. So I hit OK. It recalculated those areas. I go back into Edit Data. There's my area. Exactly what it was in GIS, which is really nice. And so pretty quickly, you can build not only what we had before, which is in this view here, but you can actually pull in all the data, which is really nice. if you had a question, for instance, let's say you're importing in and you didn't know how to import in the dry weather flow generation method, you know what that looked like. I mentioned before a handy F1. See here, maybe taking me off screen here. Well, I can show you this way too, right? Always a hallmark of the program. If you have questions of things, you can click the little button, and maybe you click here on direct flow, and what it'll take you to is our XPSWM help file. You bring it over here, and depending on the page you're going to, it'll take you directly there. And I mentioned before, under XPSWM, you can do searches, right? So I could do a quick search of dry weather, and you can see with only about 6 characters, I can look at dry weather flow. Everything that I need to know about dry weather flow. If I had specific questions about any of the formatting, that's in there as well too. So that's kind of the idea of the wiki, among other things, right? Again, you can put a lot of information in a HTML file on an online system that you just can't do on the other systems that we had before. Okay, so the last thing I wanted to show, I mentioned that we store this in a different format, and so I wanted to show you why, to me, that's exciting. So I'm going to actually jump back over to my my ArcMap, and so into a different file here, and you can see there's nothing there, which makes sense. Let me close out of this and open up a new file. It's going to be empty file here. So I did a right click for sewer sheds, but certainly you could trace that, right? You don't always have the data ahead of time. So if I wanted to trace a polygon, I can trace it, whatever that looks like. You know, I love sewer sheds, so I have my heart-shaped sewer shed. If I save that, I go back to ArcMap and just do a quick move, it's there, right? There's no scripting involved in that. ArcMap is reading that direct file. So I point that here, this sewer shed polygon, and it's read immediately. And in fact, if I have over here my web version too, same thing, I just refresh that, and there it is. Right? It's all the same data. They're all connected to the same data at the same time, and I can do editing anywhere, and they will all change together. Of course, that's subject to your business rules of where you are, but I really like the idea of pointing our GIS power users to a read-only version of the data, and so they have that data here, and they always know that it's the most accurate. As soon as I save it in XPSWM, it's automatically here. And so I mentioned I can kind of give you an idea of that. If I build something here, and as soon as I go here and just do any kind of refresh, it shows up. So really nice. Again, we will be taking that into the future and eventually getting much more of that kind of format. And in fact, the newer softwares that we're building are also stored in that type of format. And so I'm excited from a GIS user to be able to get it into this kind of format. So that's kind of a sneak peek. Again, not a tutorial on exactly how to use it, but it's a nice feature, and we have some pretty awesome users, so I'm looking forward to what you guys and girls are going to build with that. I think that's the main part of what I was going to cover on my live demo, again, trying to be cognizant of time. So I'm going to pass it back to Tony to summarize things. I know, Tony, I switched some slide ordering on there, but I think the last part here should be pretty much the same.
Thanks, Adam. I'm just going to summarize here for the next couple minutes. You know, we've seen a lot of 2016 enhancements and new features that we've presented. We tried to highlight, you know, I suppose our personal favorites or the ones that we think have the broadest appeal. However, you know, there's about 40 new features or major changes, and you know, more than 100 different maintenance and other enhancements, and they're outlined in a file called changes.txt. And in fact, that ships with the software. You could see what happened in this version and previous versions. If there's any kind of required clarification on any of those, we're more than happy to provide you more information. The changes.txt is just, you know, just several words to describe the change, but of course the impact of the change, if you'd like to know more, we're definitely willing to tell you more about it. And of course, tutorials and the help and so on may explain more about each change or new feature. Again, on behalf of all of us here at XP Solutions, thank you for your time. If you have any questions, I suppose general questions or sales questions, use the amsales@xpsolutions.com but specific questions for Adam and myself, we're happy to respond to you directly. And then again, thanks and happy holidays.